buffer is a solution that resists changes in pH. It can be made of either a weak acid and its conjugate base, or a weak base and its conjugate acid. An example of this is hydrofluoric acid and its conjugate base, a fluoride ion. Yeah, that'd be fluoride. Right. And then let's just erase that. Make some extra room. An example of a weak base and its conjugate acid would be ammonia and its conjugate acid, NH4+. Buffering capacity is the ability of a buffered solution to accept H+ or OH- ions. The best buffers have an equal concentration of the acid and conjugate base, or the weak base and conjugate acid. The higher the concentrations of the acid and the base results in a greater buffering capacity.
There are 4 different types of acid and base reactions. Otherwise, we can call them titrations. The first type of titration that we will discuss is a strong acid with a strong base. What will happen with this is that the acid and the base will dissociate 100%, knowing that they are strong. A good example of a strong acid would be hydrochloric acid, and a good example of a strong base would be sodium hydroxide. So what's going to happen now is that the hydrogen ion will go with the chlorine, go with the hydroxide ion, and form H2O. What else will happen is the sodium will go with the chlorine and create sodium chloride. And this is a strong acid, strong base titration. Another type of titration that we will discuss is a weak acid with a strong base. In this titration, only the base will dissociate 100% because it's the only strong chemical in this titration. A good example of a weak acid would be acetic acid. And we can use the hydroxide ion as a strong base because hydroxides are always bases. So what's going to happen in this case is the acetic acid will lose its H+ ion because acids will always lose their hydrogen ions. So what the hydrogen ion will do is it will create water with the hydroxide ion, aka H2O, and we will have acetate left over with a negative charge. And that concludes the weak acid and strong base titration.
The final kind of titration is a weak acid and a weak base. Because neither of them are strong, neither will dissociate 100%, so you can't get rid of any spectator ions. An example of this is acetic acid plus a fluoride ion, and that will yield hydrofluoric acid and acetate.
When actually initiating titrations, you add an indicator to signal when an endpoint happens. And the endpoint is when the solution in the titration actually changes color. Which is not to be confused with the equivalence point, which is the point that there are equal amounts or moles of both your H+ and OH- in the solution. When talking about acids and bases, it's also good to mention things that make solutions more acidic or solutions more basic. Some examples of some things that make solutions more basic are essentially anions that are conjugate bases of weak acids, or metal oxides, such as magnesium oxide or potassium oxide. And salts will have no effect on the overall pH. And for acidifying solutions, cations can do this. And they do this because they pull H plus ions free from water, and this ability increases as ionic radius increases and the charge increases.